Hi everyone. So today we are going to start with the chapter The Atmosphere. Now we are going to understand the various layers and the composition. Before that, I would like you to familiarize with the International Standard Atmosphere in order that all the aircrafts they fly from a same datum, and also for the testing of the aircraft or its performance evaluations, and for the calibration of altimeter or the various pressure instruments, a standard international standard atmosphere has been set. For that we need to learn some of its specifications. That it says that the air is dry, the temperature at the mean sea level is 15 degrees Celsius, the pressure at the mean sea level is 1013.25 hectopascals. The density at mean sea level is 1225 grams per meter cube. The lapse rate up till 11 kilometers, that is 36090 feet, it is 6.5 degrees Celsius per kilometer or 2 degrees Celsius per thousand feet. Also, it assumes that the temperature is constant from 11 kilometers to 20 kilometers, which is minus 56.5 degrees Celsius. From 20 to 30 kilometers, there is a rise of temperature at the rate of 1 degree Celsius per kilometer. This rise of temperature with height is known as inversion. Also, a topic comes into existence, ISA deviation. In order to calculate the ISA deviation, we need to find the actual condition at the prevailing altitude or the place we need to find minus the ISA value. So ISA deviation is actual minus ISA. There is also a jet standard atmosphere. The specifications in JSA are the mean sea level is temperature. Mean sea level temperature is considered to be 15 degrees Celsius. The lapse rate is again 2 degrees Celsius per thousand feet. But here there's no tropopause. So let us start with the chapter. The atmosphere, it is the gaseous envelope surrounding the Earth's surface. This gaseous layer, it is very essential for sustaining life. It protects us from the various harmful solar radiations, also helps to regulate the temperature and supports various weather systems. Now, in this presentation, we are going to cover the composition, the structure, and the functions of the atmosphere. Composition of the atmosphere. Our atmosphere is composed of various gases and some other various variable components. So, the major gases that constitutes our atmosphere is nitrogen, which is 78%, oxygen 21%, argon 0.93%, and carbon dioxide or carbon 0.03%. Also, there are traces of various gases such as neon, methane, krypton, hydrogen, etc. The variable components includes the water vapor. It is variable. Water vapor is variable in a way that in warmer air or warmer air mass, the amount of water vapor is greater than in cold air mass. Ozone and dust particles they vary with location and time. Some facts about the atmosphere. The nitrogen and oxygen it constitutes almost 99% of the air. The ratio by proportion of nitrogen and oxygen is as follows. Nitrogen is to oxygen by volume is 4 is to 1 and by weight it is 3 is to 1. Now, as we move to higher altitudes, the air gets rarefied, due to which there is rapid reduction of gases with height. So, as a result, we require supplementary oxygen above 10,000 feet. The temperature up to 80 kilometers is known as I'm sorry, The atmosphere up to 80 kilometers is called the homosphere, and above it is the heterosphere. We also need to learn about some basic terms. The first is unsaturated air. Unsaturated air is also known as dry air. This means that the relative humidity in the atmosphere it is less than 100%. The second term is saturated air. In saturated air, there is 4% of the water vapor along with 100% relative humidity. Now comes the vertical distribution of mass. Now, below 6 kilometers, the distribution of mass is almost 50% or 1 by 2, half. Below 10 kilometers, this distribution of mass is 75% or 3/4. But below 35 kilometers, 99% of the mass is available. Next is the greenhouse effect. Greenhouse effect is basically the trapping of the heat by the greenhouse gases such as carbon dioxide, water vapor, and methane. The greenhouse effect, this process it keeps the earth's temperature stable and suitable for life. What is the impact of human activity? The increased emissions of greenhouse gases it leads to global warming and climate change. All the changes in the climate or the excess of global warming in today's generation or time it is 99.9% due to the increased emission of the greenhouse gases. Now comes the layers of atmosphere. The various layers of atmosphere are listed below. We are going to discuss them one by one. The first layer of the atmosphere is troposphere. It is the lowest portion of the atmosphere. The term has been derived from the Greek term tropos, which means to turn, and sphere means the earth, which means turning the earth. Now, since there is turbulent mixing of gases, that is the only reason or the responsible reason for the occurrence of weather. The tropopause it extends from 16 to 18 kilometers over the equator and 8 to 10 kilometers over the poles. Temperature generally falls with height. That is, it is the normal layer. The lapse rate is 2 degrees Celsius per thousand feet or 6.5 degrees Celsius per kilometer. Sometimes the temperature of the air it rises with height, which means there is inversion, and in some cases the temperature is constant throughout. This means that isothermal layer is present. Inversion is negative of lapse rate. Now we need to learn that the temperature at the equator is much greater than that on poles, and tropopause is therefore much higher at equator, which means that warmer the surface, higher would be the height of the tropopause. What is tropopause? Tropopause is basically the top of troposphere, and it marks the boundary between the troposphere and the stratosphere. The surface temperature, latitude, season, the land sea distribution, this all depends or it controls the height of the tropopause. It is higher over the equator where the temperature is minus 70 to minus 75 degrees Celsius, but is lower at the poles where the temperature is minus 40 degrees Celsius to minus 45 degrees Celsius. Sometimes the tropopause abruptly changes at height. This abrupt change of height of tropopause is called breaks or folds. These are at a latitude of about 40 degree and 60 degree, but the more prominent is over 40 degree latitude. What is the importance of tropopause? All the weather activities they are confined to tropopause, and it is the maximum height in which the clouds may reach. Then comes the stratosphere. Stratosphere extends from tropopause to about 50 kilometers. For initial 8 to 10 kilometers, this layer is isothermal, and thereafter the temperature increases slowly, and towards the top it will increase sharply or rapidly. Nacreous clouds, or the mother of pearl clouds, they are sometimes present in stratosphere. Stratopause is again the upper boundary of stratosphere. Then comes mesosphere. From stratopause to 80 kilometers is the mesosphere. Noctilucent clouds are seen in the mesosphere. Mesopause is the top of mesosphere. At this level, at the level of mesopause, the temperature stops falling. Thermosphere. Thermosphere extends from the mesosphere to the end of the atmosphere, where the temperature they increase with height. But above 700 kilometers, it is called the exosphere. Now the air is very thin and has very few air molecules. These molecules they may be active and may have a very high temperature. Ionosphere. The atmosphere above 60 kilometers is called ionosphere. It is important for radio wave propagation. Conclusion. The atmosphere it is a very vital component of the Earth's system and is essential for protecting and sustaining life. Understanding its composition and functions, it is very crucial in addressing the environmental challenges like climate change and pollution. Collective efforts are needed to preserve the atmosphere for future generations. Thank you.